Okay, so we have discussed briefly in the previous one or two videos, the previous few videos, the normal distribution. So now we kind of get straight up here and we just want to talk about the standard normal distribution, The standard normal distribution is always in z-scores. The horizontal axis is always in z-scores. And a z-score is the number of standard deviations we are above or below the mean. If we're in z-scores, which we always are, the mean is in the middle is 0. What do we know about the normal distribution? We always call it the mean, but it is the mean, it is the median, and it is the mode. They're all the same number right in the middle. So there's always exactly plus or minus 3 standard deviations, and the standard deviation is 1, so it goes +1, +2, +3, -1, -2. So we're not going to draw this too often. It just takes too long. This is just kind of a short lecture. So for the most part, that's it. We talked about this a little bit in the beginning of the video series, which is good. Obviously, this is mound-shaped, but this is a dome, as opposed to this has nothing to do with, right, something that has nothing to do with, but it has nothing to do with the discrete probability distribution, which is always, kind of, it's not really a graph, but it looks kind of like that xp of x, like a plot or something. We just call that a discrete probability distribution. So what is this? This must be a continuous random variable. Yes, all normal distributions, which are weights or some sort of measurement, all normal distributions are continuous random variables. That's basically always true unless we do some sort of a kind of unusual thing. Yeah. But something interesting about continuous random variables, it's true about the normal distribution because it is a continuous random variable. Yeah, but something interesting about it is mathematically impossible to find the probability that x equals, say, 1.5. They simply do not do this. Find the probability that x equals this. 2. Find the probability that x equals -0.5. They only do between two values. They do not find the probability that x equals a number. The area is the probability, and you find, for instance, what's the probability that z equals 0.5? It's an infinitely thin line, so mathematically it's 0. So basically, with a discrete probability distribution, you find the probability of a number 0, 1, 2, 3. You don't do that with continuous. With continuous, we only find the probability that we are in between two numbers. Find the probability that z is between. And a single line, I know every little thing we're not going to understand, but a single vertical line, as we said, is infinitely thin. So it doesn't matter if you have less than or equal to, those, they are calculated the same way, but it doesn't matter that. So let's just say that we have a 0.5 to 2. Yeah, the probability that we're between 0.5 to 2 is going to be that shading. The shading is the probability. So that's basically it for the normal distribution. The normal distribution is probably the most important distribution in all of statistics. There's a lot of things in the world that are approximately normal. Are there things that we should say? So yeah, there's 3 basic things. You can do greater than, which we call right-tailed. We can do less than, which we call left-tailed. Or we can do between two values. Yeah, so any shading, you can find the shading is the probability. Okay, so that's fine there. Anyways, we just want to do these problems. I'm making it way too complicated, yeah. But that's what that is in the upper right-hand corner. So how do we do this? To find the probability that z is, yeah, it's not the mean there, is less than, it doesn't matter if you say less than or equal to, it is the same thing. 0.17 is going to equal normal CDF. It's always going to be the low, the high, the mean, the standard deviation. Now the low is negative infinity. Yeah, so we have to do E99. So we do negative E99. The low is negative E99, comma, the high is 0.17. The mean is 0, and the sigma is 1. I get approximately 0.5675. Okay, good. So this is usually one of the easiest parts of the class. Yeah, we're supposed to draw this thing for kind of good practice or something, but they give us that, yeah. So remember, it's always normal CDF. It's always low, comma, high, comma, mean, comma, standard deviation. That's always what it's going to be. Yeah, so the probability that Z is greater than negative 0.91 is going to be normal CDF. Negative 0.91 is the low. The high is infinity, so E99, comma, mean, comma, standard deviation. With the standard normal distribution, the mean is always 0, the sigma is always 1. Okay. I get 0.8186. Okay, so normal CDF. It is second vars. That's where it's located. Yeah, second vars, and we scroll down. This is number 2 usually in the list, normal CDF. Okay, so we do get 0.7183. Okay, so there's only 2 basic things. There's inverse norm and there's normal CDF. So normal CDF, of course, will find the area between 2 values. Normal CDF will find the area is the probability is the area. We'll find the shading between the low and the high. Okay, so we have the inverse. If we're given a probability, which is a shading, the inverse norm will give us the Z or the X value that's related there. We've only talked about the standard normal, what do we call it? The standard normal distribution. So usually you have a word problem, you have like some actual mean that's not 0 in a sigma, we have to kind of make it up. But like the weights of all men, the mean might be like 170 or 180 or something. And then it would be like 20 or something like that would be the standard deviation, which of course is that length. Yeah, so we do all that. But this is inverse norm. So inverse norm does the area to the left. Inverse norm is not going to do area to the right. Inverse norm is what's left-tailed. So we have to input that shading, that probability, and it'll give us that Z or X value. We have to input this shading or this probability. The shading is the probability, and it will give us this X or Z value. And, we can do anything to the left. What if we have to do an example? I didn't say this in the beginning, where it's a shading to the right. The inverse norm doesn't do that. Well, remember, the total area, the total probability under any complete curve is 1. This is a probability distribution. The total area under the entire thing is 1. So if you have the shaded on the right, let's just say that's 0.2 or something. 1 minus 0.2 is 0.8. Yeah, so the 2 add to be 1, and we would have to inverse norm the 0.8 to get the Z value right there. And inverse norm is very useful for percentiles. Inverse norm and percentiles are more or less the exact same definition. If I do within the 90 percentile on the test, I get a score on the test here, and I'm within the 90 percentile, those words within the 90 percentile always seemed a little strange to me, because 90 percentile means that you did better than 90% of the people who take the test. So percentiles are automatically left-tailed, and inverse norm does left-tailed. Anyways, blah, blah, blah. So we find that by inverse norm. So it is inverse norm. Alpha usually is for area, comma mean, comma sigma. That's the syntax. Inverse norm. It is that area 0.9830, comma 0, comma 1. This is a z-value, 2.12. Stats is just so exciting. Okay, so we have it right there, yeah. We want to find the z-value such that the right is 0.1762. We cannot do that in inverse norm, so 1 minus is the left. 1 minus 0.1762 is approximately 0.8238. We inverse norm 0.8238, yeah, comma 0, comma 1. If you just do, it's just syntax. With most calculators, there's too many TI-84, TI-83, TI this and that, Silver Edition Plus. There's too many over the years to say that it works this way. But most any graphing calculator, as long as it's Z, the mean and standard deviation is more important when you have an actual word problem. But if you're doing Z-scores, you really don't have to type those if you don't want, usually. We say inverse. That should say inverse norm. So just 0.8238, and usually the mean and standard deviation are already in there somewhere. Hmm. 0.17, 0.8238. And I get 9299, which they say is wrong. What the heck happened? Inverse norm. Yeah, that's not the value there. Oh, just to 3 decimal places. Thought it was a probability, it was a z-score. Okay, so now we have a problem, of course. So that's going to be, it's always the same. We want that area. The procedure does not change. Yeah, remember, negative infinity. That seems like a strange concept to some people, left-tailed negative infinity, but we have to type in any large number. Negative 9999 is fine. Comma 85, comma mean is 100, comma standard deviation. So if we have an actual word problem, then we definitely need mean and sigma. And what is it going to give us? It's, well, the area, but the x value is 85. What is the probability that x is less than 85 is what the problem is. And they're talking about like IQ scores or something. That just takes a minute to erase the board here. Yeah, so we have normal CDF 85 to 125. So this one would be the probability that equals 85. Okay, yeah, so it's like the probability that x is less than, some x value, and we're trying to find that x value equals 0.85. Yeah, so do inverse norm. Yeah, okay. Okay, so these are basically the same problems here. So they can give us more interesting problems, and we just see if they mix in any other concepts. Yeah. So a survey found that women's heights are normally distributed with mean that and standard deviation that. A branch of the military requires women's heights to be between 58 and 80. Find the percent of women meeting the height requirement. So wait, I kind of read this and don't understand. Yeah, but a branch of military requires women's heights to be between those two numbers. Yeah. So we have that. Find the percentage of women meeting the height requirements. Are many women being denied the opportunity? Okay, so we can do that one pretty easily. What is B if the branch of the military changes the height requirement so that all women are eligible except the shortest 1% and tallest 2%? What are the, okay, so I can see the problem now. So with these, we're always supposed to make a little bit of a sketch here. And we can label the mean and the three standard deviations above and below. My picture isn't very well, but it's not very important. What's most important is really just to label the mean, the center, 63.6. So know that 58 is something like down here. It doesn't matter how well we have that. 80 might be somewhere up here. Those are literally the values right there. So we're literally going to find the normal CDF, find the area in between there from 58 to 60 is what that is. So find the probability that x is between, yeah, 58 and 60. Yeah, that's 58 and 80. I'm looking at this like, what the heck? Okay, good. So normal CDF, low, high, comma mean, comma standard deviation. Uh, and that's the probability that a randomly selected woman from whatever the population is in between that. So 4 decimal places, or we do it to a percent. Obviously, things come out as a decimal. A percent to 2, I get 98.75 is what I get. Yeah, hopefully we understand for percent, just carry the decimal 2 places. Okay, good. So within all of that there's less than 2% that are denied, supposedly because of that. A lower than 2% chance. What the heck? But 98.25% of them to meet the height requirement rounded 2 decimal places as needed. 98.75. Yep, 75. We would say no there. Which one is it? We get two guesses. We read through that, and whichever one they want. The answer is no, that not very many are being denied. So we have that. And then we do inverse norm, yeah. So what do we have though? This is kind of a good tricky question. Basically, if we have one question that kind of describes everything in one fell swoop, that's good. So we don't want decimal form. Uh, yeah, we do want decimal form. I mean that we don't want percentage. When we do inverse norm, everything has to be a decimal. But we literally have the shortest 1%, yeah, which would be inverse norm 0.01. If we have the tallest 2%, 0.02, we agree that everything to the right is 0.98. So we have to inverse norm. It is a, yeah, area mean standard deviation. Um, it is going to be alpha comma sigma, alpha comma mean comma sigma. So 0.01. Yeah, comma mean 63.6, comma standard deviation 2.5. Yeah, and then inverse norm 0.98, all the same stuff. 63.6, 2.5, and then we get that, and then we get this. And then those are going to be the x values round to 1 decimal place. Those are going to be the heights. So normal CDF will find the probability that we're in between two heights, two x values. An inverse norm will take a probability or an area and link it to that x value. Yeah. Eight, 68.7. Good, good, good.